SAT 22 for week 26. Let's take a look at our question here. The dot plot represents the 15 values in a data set A. Data set B is created by adding 56 to each of the values in data set A. Which of the following correctly compares the medians and the ranges of data sets A and B? And we have ourselves the traditional multiple choice. How did we do? Well, rather spectacularly, if I may say. You can see that here we have this huge slice of the pie, 83.8% answered marigold. I think that's marigold. Answer choice C, which was in fact the correct answer. Nothing's even close. And we said that it was, well, sort of easy, but there were a few. There's another spike there, right there at medium, but mostly easy. So let's take a look at the solution, and in doing so, kind of review some of the terminology in this statistics kind of question. So when you have a set of data like we have here, this is called a dot plot, by the way, where we're just being able to see pretty easily the frequency with which each of the data numbers come up. Like, for example, I've got 5 of these 22s, I've got 4 of these 23s, and so on. So if you've got a whole set of data and you don't want to have to look at all the numbers, is it possible that you can summarize the whole set of data in just a single number? And we have lots of ways to do that. And we usually call them measures of central tendency. Tendency? Now, this E right here could be an A. I'm not sure. Ask your English teacher. So what this means really is that the word central, of course, means middle. You're looking at something that's associated with the middle of your data as a way to summarize the data. And there are basically 3 of these. The first one is the mean. And the mean is the one that most people associate with average, where we'd add up all our numbers and divide by however many we have. In this case, it'd be 15. Okay, and then we have ourselves, let me show you that this is the average. Okay, then we have ourselves the median. Just like the median of a road is right in the middle, same thing with a set of data. If you were to order them from smallest to biggest or biggest to smallest, it is the number that is right in the middle. Now, you can only have a middle number if you have an odd number of data points, which we do because this has got 15 numbers in it. But if you had 14, what you'd have to do is you'd have to take the average of the 2 that were in the middle. Okay, and then there's one more. You have the mode. The mode is the one that occurs the most. And that one's pretty easy to see in a frequency dot plot like this, because you can see that's going to be 22. So, like I said, these are ways to sort of summarize that set of data. Now, as far as that summary goes, let's say, for example, you're sitting in class and the teacher tells you what the average of the test was for the whole entire class. You get a grade and it's like 75. Well, how valuable is that 75 as a measure of the central tendency of all those grades, as a summary of all those grades? Well, it sort of depends. It depends on one factor, which is how spread out that data is. And we have a way, we've got a number of ways, but there's one way that you guys know to measure how spread out the data is, and that is the range. And the range is just simply the biggest number minus the smallest number. And it's a way to measure the variability in your data set. So it's like this. Let's say that your numbers are really far apart. Whenever you subtract the biggest one minus the smallest one, it'll tell you how far apart those numbers are. And maybe these measures of central tendency aren't quite as valuable as if you have a smaller range, and that smaller range would indicate that your data is more compact. It's more closely related to a single number. Okay, so now we have all of this summary out of the way. Now let's take a look at what it's actually asking us to do. What it's asking us to do is just basically compare the medians of the 2 data sets and the ranges of the 2 data sets. So whenever you have yourself, like I said, an odd number, the median's very easy to get because it's just the middle number. So if I have 15 divided by 2, 15 divided by 2 is 7.5. So I should have 7 data points on one side and 7 data points on the other side, meaning that the eighth one should be the median. So if I just count these off, 1, 2, 3, 4, 5, 6, 7, 8. This one is the middle number here. And I could have counted that from the small side, or actually the big side. 1, 2, 3, 4, 5, 6, 7, 8. And again, 23 is the number that's right in the middle. So that's your median for this data set. Now, if you were to take each one of the numbers in your data set and add 56 to them, well, you're going to have the same number of data points. It's just that all of the numbers are going to be 56 units bigger. So instead of 22, you'd have 22 plus 56, which is 878. So all of these numbers would be 78. And all of the 23s would be 79. All the 24s would be 80, and so on. So this would be 81, and this would be 82. And now if I do the exact same thing, where I find the eighth number in this list, it's still this same green dot that's right here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, look at that, it's 79. So for the new data set, so I will say that this is A, and this is median for B, that's equal to, I can see there pretty clearly that it is a 79. What's the difference between these two things? If I take 79 and I subtract 23 from it, that's a 6, that's a 5. 56, does that number look familiar? It should, because that's what we added to each of our data points. So essentially, we just translated our data, all the numbers, 56 units to the right, which also affected our median by just increasing it also by 56. So let's just look at our answer choices, because maybe we don't have to do anything else, because maybe that's the only one of the answer choices that says that our median increases by 56. So on A, it says the median of the data set is equal. You're done. By done, I mean A is done. That's garbage. On B, the median of the data set is also equal. Well, that one's also done. So we don't care about it. So it's just between C and D. And both C and D say that the median of the data set is greater. So far, we're now down to a 50-50 chance to get this right if we just guessed, if we didn't know anything about range. Now, range, as we said, is the biggest minus the smallest. So let's just calculate that for each one of these. So if I talk about the range of A, my biggest number here is 26, and my smallest number was 22. This is equal to 4. We have a range of 4. So that's significant, because with the numbers that we have, we're saying that from the smallest to the biggest, there's only 4 digits difference. So it's a fairly compact set of data. And you can also see that in the picture, like the little data points aren't very spread out. Now, if we take our range for our set B, do the same exact thing. Remember that our biggest number now is 82, and our smallest number is 78. Believe it or not, that is also a range of 4. Well, why did the range stay the same, but the median got bigger? The reason why is because we just took all of our numbers and we shifted them to the right by 56 units. However, the difference between each of the smallest and the biggest number, though, remained the same, because we added 56 to both of them. And so the difference between them still remained to be 4. So now let's look at our answer choices, and we're looking for one where the range stayed exactly the same. So let's see. On C, it says the range of B is equal to the range of A, and we have found our answer, which means probably that D says that the range is bigger or smaller. It says that it's bigger, but it's not. So if you did choose D, which is tempting to say that the range gets bigger, you might be thinking that range means, well, what is the smallest number? What is the biggest number? And so you're just simply saying that your range is, for example, from 22 to 26. However, it's not that. As we were just talking about, the range is the difference, as in you subtract these two things. So it's not actually like we're saying, hey, this is the interval over which our data occurs, which is the kind of thing that you associate with the functions. But for data sets, it's not exactly the same thing. Okay, so more or less that is the solution here. However, I'm going to take this a step further and show you that you could do some of this kind of stuff on Desmos. Would I recommend that you do this on SAT? No, because you'd be wasting so much time, because it actually takes quite a bit of time to enter this stuff into Desmos, but I will show you how to do it. So if I open up some Desmos, boop, I'm going to show you how to actually put in a list of data. And that's exactly what it's called. It's called a list. First of all, I want to name the thing. And I tend to use like a capital letter for the list. And L is a pretty common one to use. And then we're going to set it equal to our list. Now, in order to put in a list, Desmos requires that that list go into a square set of brackets like this. Now, the brackets that are right beside it, that's usually for it's usually for a range of numbers, as in for a domain or range of a function. But for a data set, we're going to use the closed brackets. And now you just type in all your data numbers. And remember, we had, I think, 522. So there's 1, 2, 3, 4, 5. And then you separate them all with commas, okay? And then it's increased by 1. So then we had, I think, 423. So 23, 1, 2, 3, 4. Oh, what are these parentheses? I don't even know. So that's a comma. My big old thumb's got in the way. All right, anyway. Oh, it looks like I did another one over here. Oh, I don't want that in there. Okay, so it just keeps wanting me to put parentheses around this. Anyway, let's keep going. And then we had, let's see, 24s. There were 3 of these. And then why don't you separate those with a comma? 4, comma, 24. Do you see how much time this is taking? Anyway, and then 24, 21 was a 25. There were 2 of these. And then we had 25, and then we had a 26, just one of them. Okay, so it is freaking out with this set of parentheses here. So let me see if I can get rid of them, because that should have just finished it off. And with your mouse and keyboard or whatever, or your little trackpad, this might be a little bit easier than it is on iPad to scroll all the way over here. Now hit the little, okay, there it goes. And it does confirm that we have 15 elements. Element means individual number in that list. Okay, and that whole dot plot thing, that is a way to help you visualize this data, which is available under the functions, or you can just type out the word dot plot, and it is under visualizations. Dot plot is that one right there. And inside the parentheses, you just put the letter, or you can actually type in your whole set right there. But the benefit of doing this with assigning it the variable L is that now I can do the math on it as well. So I'm just going to put an L inside here. And it assumes this bin width as 1, which you can just leave as the default, and it's fine. Okay, and that doesn't look like it did anything, but it actually did plot your data. It's just that, look at where we're at on the graph screen. It's going up to a maximum of x is equal to 10. So if you hit the little magnifying glass, it'll just zoom into where your data is. And look, that should look really familiar to you, right? So you count off your data. There's 1, 2, 3, 4, 5, 6, 7, 8. There's the 8th one. That was the one that represents the median. As a matter of fact, you can actually find the median of this pretty easily. You can either type in the word median, or you go to the functions. It's under stats, and there's the median button, and then just put the L right up inside of that. That's why I said that it's actually pretty handy if you name your data set. That way you don't have to keep typing it in 1,000 times. Okay, and then, now there isn't a function for range. And instead, if you wanted to manually compute the range with your data set, what you'd have to use are the 2 functions underneath the stat menu, which is the maximum and the minimum. So you'd have to do the max of L, and then arrow out of these parentheses minus the minimum. And go back in here. You can see that's kind of time costly, but it's pretty easy visual check to just see what the biggest number is and what the smallest number. If you had a huge set of data, maybe that this would be a little bit more advantageous, but for this example, it would have been easy to just look at the data and go, oh, here's the biggest, here's the smallest, let me subtract those. Anyway, so there is the range. And let's see, the other data set that we were looking at was adding 56 to each one of these numbers. And so let's say that we're going to start ourselves a new list. We'll call this K. I guess I could have called these A's and B's because that's what the original problem was, but whatever. Didn't think of it at the time. So equals, and then put in a square bracket, and then this is very nice as then it does the arithmetic for you. So let's just say that you couldn't think what 22 plus 56 was. It tells you right there it's 78. Okay, so I'm going to start with 78 and put in all of these 78s. So 78, and there's 5 of them. 2, 3, 4, 5. And then just increase each one of these numbers by 1. So 79, there's 4. And then 80, there's 3. 81 and 182, right? And there's your confirmation that you have 15 numbers in this thing. And then let's do the same things that I did for the other set, which was let's visualize it with a dot plot and then put in here that this one is K, and then maybe zoom in on that data. And both sets of data are still in the same graph, you can see. And, oh, if you look at this, it's pretty easy to see that what you did, of course, is just shifted to the right your whole entire data set by 56. Anyway, so we'll be able to see that here in just a second too. So let's do the whole median bit. So coming back over here to functions or typing in the word median, I will see that the median of K is not 23 as before. What did I want to do? I think I wanted to put K in there. That's right, it's 79. And then of course, if you just took your 79, and then you subtracted your 23, I wonder what number we'll get. Oh, it's that magic 56. Okay. All right, and then what about the range? Well, the range you can do exactly like we did before. And you know what? I have discovered that there is a way to copy and paste here. So what you do is you go to the little gear, and then you hit the little copy button that's to the left of the X here. So just copy this. No, I didn't want to copy that one. I wanted to copy this calculation right here. There we go. Then I go back to done, and then change these L's to K's. That might be a little bit faster. L times K. Okay, and then over here, do the same exact thing, and you can see that this is wasting way more time than you'd ever have. However, I mean, this does have like some applications outside of just the SAT. Whenever you have a data set that you're trying to do some analysis on, there's some kind of statistical tools that you can do that with. But anyway, you can see that the range of the other data set is also 4. Now, one of the things that they could have done with this question, instead of just simply talking about the median and the range, they could have also done the same kind of thing for mean. So I think that this question could be adapted just a little bit more and substituted mean in that place. And so let's just see with the data sets that we have in Desmos how that affects each one of these. So remember, mean would take all the numbers, let's say, for example, all of the numbers in set L here, add them all up, and in this case, divide by 15. So what the question could be changed to is that how does that affect your average? Does it also increase or does it stay the same? So put your guesses down in the comment section. No, for real. If I just go over here to our stat functions and this time choose the mean, and then I put in an L value here, there's the mean. You can see it's pretty close to what our median is. And that's another indicator that your mean and your median are pretty good summaries of the data. The two numbers are pretty close to each other. And then if I did the exact same thing for the other data set, is it going to be the same number? There's no way it could be the same number. All of our numbers are bigger, right? So if I do the mean and then put a little k in there, And you can see this one is 79.333. And if I notice, that's really close to the median for that other set, that's set K. And I wonder what the difference between those two numbers is. If I were to subtract these, I know the 0.3s would just kind of cancel out. They would subtract away. So just do the 79 minus the 23. And then once again, you get 56. Who would have guessed? So if you just add the same number to each of your data points, it does the exact same thing to the mean, which is it will also shift that to the right by that same exact 56. All right, so that should do it. I think this video has gone on long enough.